Okay, so let's take a second to talk about rotations. There are two ways that you can rotate something. You can rotate it clockwise, which means it goes in the direction of a clock. Ooh. Or you can go counterclockwise, which means you go the opposite direction of a clock. All right. So if I look at this figure, if I want to rotate it, I would literally turn the figure. That's a rotation. A rotation is just a fancy math word for turn. So I could take this figure, if I want to rotate it clockwise, I could turn it in the direction of a clock, and this would be 180, well, not exactly perfect, but that would be a 180-degree rotation. Now, if I wanted to rotate it 180 degrees more, I would turn it, and it would end up back where it started. Anytime a shape ends up back on top of itself, in math, we say that it maps onto itself. So that's an example of 180 degrees clockwise rotation. Let's say that you wanted to go counterclockwise. You would just rotate this sucker. So if you wanted to go 90 degrees, or you could go 180, or you could go 270. Anytime you rotate, oh, that's not exactly perfect, but anytime you rotate, you are just turning the figure. So if you had two images and they look something like this, we don't know exactly how far they rotated it, but we know that's a rotation because that figure is being turned. All right? So that hopefully will help you identify rotations. We also want to talk about something called rotational symmetry. So let me change out my pictures here. Okay, so I have this funky looking shape. I don't even know what it is. Doesn't matter though. And this shape has rotational symmetry. And what I mean by that is I can rotate it and it will end up mapping onto itself. In other words, it looks the exact same and it lies back on top of itself before I've gone a full 360-degree rotation. Every figure has a rotational symmetry of 360 degrees, so we don't consider that rotational symmetry. We're looking for some kind of degrees less than a full rotation to see if it has rotational symmetry. So this does, we can actually rotate it, that's the second time, and then we can rotate it one more time, and that's the third time, and that got me right back to where I started. So we can rotate this 3 times within one 360-degree rotation. So to figure out the angle of rotation, the angle of rotational symmetry, you could take your calculator and you could do 360 divided by 3. And that tells you that you have rotational symmetry every 120 degrees. And so, you know, you're not going to actually pull out a protractor or whatever very often, but I just want you to see what that's saying. So if I line this up, okay, so I've lined it up here, and then, let me pull my little figure out. Oops. Okay, so basically if I take this figure, I've lined it up, and I go to where it says 120 degrees, if I rotate it that far until that pink line is right at 120, you'll see that it maps onto itself again. And if I did 120 again, you would see that it maps onto itself. So this has rotational symmetry of 120 degrees. In other words, every 120 degrees, it will map back onto itself. So 120 works, 240 works, and 360 degrees works. So that's a little bit about rotations, and I hope that helps.